Let's work through an example with some real functions in it now. So we're looking for the partial of z with respect to u. Our outer function here is a function of x and y, and we also note that our two inner functions are really functions of u and v. So we are asked to find the partial with respect to u. So let's get started on that. Now the tree is often a good place to start. So we have our function. I'm going to call it z because that's what we've been calling it. And again, it's a function of x and y, and each one of those is then subsequently a function of u and v. So when we set up our tree, I'll use the z notation here to represent f of x, y, because that's what we've been doing. And when we take the derivative, then we've got our two partials, so we need a branch for each one of those partials, and then they will subsequently break into partials with respect to u and v, so we need to branch that as well. I'm trying to give myself enough space here to write in all of our notation. Okay, so let's go ahead and fill this in. This is going to be the partial of z with respect to x. This is going to be the partial of z with respect to y. Here we're going to have the partial of x with respect to u and the partial of x with respect to v. Here I've got the partial of y with respect to u and the partial of y with respect to v. And of course we can form then from here all of our individual chain rule problems. So let's just write all of that out just so we have it. And this is all just to set the stage so we know what it is that we're trying to compute. So partial of x with respect to u, partial of z with respect to x times partial of x with respect to v. Down below I've got the partial of z with respect to x times the partial of, down below I've got the partial of y with respect to u. No. Down below here we've got the partial of z with respect to y times the partial of y with respect to u, and the partial of z with respect to y times the partial of y with respect to v. So again, what we're looking for is stuff involving u, since we're looking for the partial of z with respect to u. So that would indicate to me that I need these two pieces here to form my partial derivative. So let's grab that and set up our equation. So we have that the partial of z with respect to u is going to be equal to the partial of z with respect to x times partial of x with respect to u plus the partial of z with respect to y times the partial of y with respect to u. Okay, now we've got it all notationally set up. Now we have to actually make the calculations themselves. So here's our function. We'll go ahead and take its derivative now again with respect to x for this first piece. So that would give us, here we're going to have 6x to the first. So that'll be the first part of that partial. Oh yeah. Then we would go ahead and take again the partial here with respect to x, which is going to be minus 2y, and then the derivative of y squared with respect to x is 0. So now I've got that first piece. It's 6x minus 2y. I put parentheses just to make sure I don't miss any distribution that I might need. So now let's find the partial of x with respect to u. So here's x. I take its partial with respect to u. the derivative of the first term with respect to u is 3, and the derivative of the second term is 0 with respect to u. So we're just multiplying times 3, plus, now we'll go back and take the partial of z with respect to y. So here we are again up here. Partial with respect to y for the first term is 0. The partial with respect to y for the second term is just minus 2x. And the partial here with respect to y is plus 2y. So that's now the partial of z with respect to y. So plus, and it's 2y minus 2x, just reversing those to keep my negative in between. And now we take the partial of y with respect to u. So here's y. The partial with respect to u of the first term is 4, and the second term is 0. So we're multiplying times 4. Effectively, that's representing, again, that derivative of the inner function, or what I like to call the cow's tail. At this point, it's just simplification, and we would have 18x minus 6y plus 8y minus 8x, and it looks like our partial derivative then, the partial of z with respect to u, is going to be equal to 10x plus 2y. It would go about the same for finding the partial of z with respect to v, but for this problem we'll just do the 1/2. I brought down our two equations here for x and y because sometimes we're asked to go ahead and put this final form in terms of the variables u and v. So it's really just a matter of substitution. Partial of z with respect to u is going to be equal to 10 times x, where x is 3u plus 2v, plus 2 times y, where y is 4v minus u. And then from there, it's just some simple algebra to combine like terms and finish that off. But at the very least, we should be aware that we are sometimes asked to put the final problem into that form.